All right. So indices rules. Well, let's let's first of all remind ourselves what these things mean. When I write I'm going to just zoom in a bit here. Um, when I write a squared, we know that it means a times a. And when I write a cubed, we know it means a times a times a. So this is kind of what we can imagine this power or indice is defined as. It's how many times you multiply it. So it's kind of weird to think, well, what would happen if I multiplied it did it to the power of a half? What would that mean? Now, you may know what it means, but what I want to make sure is that we understand what it means. So let's go through these ones here and think, let's increase this list and go the opposite direction. So if that's a squared, that's a cubed, then what would be a to the power of 1? Well, as we go from a cubed to a squared, we're dividing it by a, aren't we? So if we carry on dividing it by a, we just get a. So a to the power of 1 is just a. What about a to the power of 0? Well, if I continue with the pattern, dividing it by a to the power of 0 would be 1. So, in other words, anything to the power of 0 gives us 1. So you may know that, but using this understanding, this definition, and to kind of break it all down, it makes a little bit more sense why. What about a to the power of minus 1? Well, that would be 1 over a, right? And I'm not giving myself enough space now, so I'll zoom that. Maybe I could just shrink that and zoom in. So a to the power of minus 2, you can probably see what's going to happen now. It's going to be equal to 1 over a squared. Okay, now you may know what would happen if I did a squared multiplied by a to the power of 3. You may know that it's a to the power of 5. Again, we want to understand the reasons why, though. A squared times a cubed, as it says here, is going to be a times a, which is the a squared bit, times a times a times a. And we can see that that is what a to the power of 5 is, right? Likewise, we can have a look at one of the other rules. We'll bring a summary of the rules in a moment. We're working slowly up to this one here. So let's go a cubed all squared. You may know that's a to the power of 6, but let's understand why. So it's going to be a times a times a, and all of that is squared. Well, that means it's multiplied by itself twice. So that means I take this and I multiply it by itself. That gives me a to the power of 6. So we understand this rule and this rule. Let's do the a to the power of 5 divided by a to the power of 2. You may know that what you do is you take away the powers. Let's understand why. So we'll take 5 a's. This is a to the power of 5. I'm going to move this. This is one that we're going to be working towards understanding. And and this one is divided by a squared. Now, we know from how division works that we can just cancel these out. And so you can see that really you're just subtracting the 2 from the top. So it's just going to be the same as a to the power of 5 minus 2, which is a cubed. Okay, so we've got these are the first 3, and we've got this one here as well, which we should now sort of understand to some degree. We've got the minus ones as well. So the hardest one to understand are these fractions. We know that if we look at this first one here, breaking it down, we can say a to the power of b multiplied by a to the power of c is equal to, actually maybe that's not the best one to look at. Maybe we'll do a to the power of c multiplied all to the power, sorry, a to the power of b all to the power of c. We know can be worked out by a to the power of b times c. That's basically what I've done here. Right. Now, sorry, yeah, it is actually this rule I want to be using, this one here. So let's go back. So I did do a to the power of b and then multiplied by a to the power of c. We know in that case it's going to be equal to a to the power of b plus c. So in other words, what about if I were to multiply this by itself? Well, using this rule that we've proven up here and sort of written it here, we would see that that's going to be a to the power of half plus a half, which is a to the power of 1. And in other words, a, right? So, and we know that a to the power of half multiplied by itself is just means means it's squared. So a to the power of a half all squared is equal to a. Well, I could rearrange that by square rooting both sides. And so if I square root the left-hand side, it cancels out the square feature. I have to square root the right-hand side, so I end up with that. So in other words, a to the power of a half means the square root of a. So does it mean then that a to the power of a third means the cube root of a? That would be a good guess, wouldn't it? Let's see if it makes sense. A to the power of 3, a to the power of third, multiplied by a to the power of third, multiplied by a to the power of third, should be equal to a to the power of 1/3 plus 1/3 plus 1/3, in other words, a to the power of 1, or in other words, a. And we can see here that that would be the same as saying a to the power of a third all cubed. And so therefore, to rearrange it, I just need to cube root both sides because that'll cancel out the cube. And therefore, we can see that a to the power of a third means the cube root of a. All right. So let me just pause for a moment. Okay. So what about something a little bit more complicated like a to the power of 2/3? Well, a to the power of 2/3 would be equal to a to the power of a third multiplied by a to the power of a third, because 1/3 plus 1/3 equals 2/3, and we can see from this that that is just simply a to the power of a third all squared. And we know that from this bit here that a to the power of a third is cubed. It just means the cube root. So a to the power of 2/3 would just be the cube root of a and squared. So you could put the square here, but you could also put the square here. I won't go into detail why that ends up being the same thing. It doesn't matter if you cube it before or afterwards, but I feel like that's going a bit of a tangent. But it's that's what it means. So in other words, so now without proving that anymore, but now we've understood the rule. Maybe we could just generalize the rule now. So if I say a to the power of b over c, that would mean the cth root of a to the power of b. Right. So, for example, if I wanted to work out a to the power of 4/5, let's say I wanted to do, I don't know, I can't think of a good example now. Let's say I want to do 8 to the power of, no, let's say, let's do it the other way around. Let's go 2 to the power of, and I'll do 3 over 2. That would mean, that would mean 2 cubed square rooted. Let's change it because I want it to be a whole number. 4. So it could be 4 cubed or square rooted, but that's the same as, identical to saying square root of 4 cubed. So because they're the same, you just decide which one you want to do. If this is a non-calculated paper, which one can you more easily do in your head? I would personally probably choose that one because I know the square root of 4 is 2, and I know that 2 cubed is 8. So that would be 8. Okay, so what we'll do then is I would like to produce some general. I'm going to get the work. I'm going to get sort of like a little poster of all the rules. I'll make sure that they're all clear, and then we'll have a go at some questions. Right, so this, they've just used X instead of A and different letters for the powers and so on. But this summarizes everything I've done. You get this little dot like that. It just means multiply. But yeah, that's all fine. That's everything I've gone over. So, okay, I'll stop the video there and we'll have a go at some questions.